In this video, I'm going to be showing you how to do an analysis of covariance in JMP. So this is what my dataset looks like for that piglet dataset from the lecture. So I have 3 different treatments, and I have 10 different piglets that receive each treatment. So what I'm interested in is the treatments in this case are diet. I want to see if diet affects what their end weight is. So this is my response, what their weight is after them being on the diet. But I have a strong reason to believe that their end weight will be influenced by what their initial weight is. So the first thing I need to check is what is the relationship between initial weight and end weight before I propose a specific type of analysis of covariance model. So I'm going to go to my graph builder. And so I'm looking at the relationship between end weight and initial weight, temporarily right now ignoring the effect of the treatments. So this is going to be the scatter plot, and JMP is going to try to give you an approximate flexible relationship of between initial weight and end weight. It's not going to assume a linear relationship. So I can kind of modify this by changing the smoothing parameter. And so the further to the right you move it, the closer you're going to get to actually fitting a simple linear regression. And the further left you move it is going to be a more flexible model. But it looks like for the most part that this linear relationship does a pretty good job of capturing the majority of the variation in this data set. So the next question is this consistent across all of my different treatment groups? Is there a covariate by treatment interaction? So I can look at this graphically by taking treatment and dragging it to overlay. So it's going to look at all these different groups and their relationship. So it looks like the slope is pretty consistent across the 3 groups. One thing I'm slightly concerned about though when I see this is that treatment 1, although it's kind of consistent relative to 3 and 2, it doesn't have the full kind of covariate distribution that the other treatments do. So treatments 2 and 3 kind of get covariate values from this whole range, but treatment 1 are just going to be from 15 and up. So that could potentially introduce bias because the average, if I did an analysis not considering the covariate, because the average for my treatment 1 is going to be influenced by the fact that it had higher covariate values versus treatments 2 and 3. They're going to be a little bit more down there. So that's something to consider whenever the individual treatment covariate group means are different, that you could be introducing bias if you didn't include the analysis of covariance. And of course, that's one reason why we include the analysis of covariance. So if I wanted to look at what I might expect if I didn't do the covariate in my model, I can remove initial weight and treatment. And so what I would want to look at is just maybe a side-by-side box plot comparison of end weight for these 3 different groups. And so I would move treatment down to the x-axis, and I would click on this box plot option right here. So it looks like there might be some differences between the treatments, but what's really worrisome in this case is how much variability there is inside of each group. Now what the plot we just saw showed us is a lot of this variation could be potentially explained by the covariate. The variation the values had about the line was much smaller than the variation about their mean. So we're going to look at fitting a couple different models and see the impact of including a covariate in our analysis. So these initial weights right here are not centered. These are the raw initial weights. So we talked about using the centered model. So if I want to make this centered, I have to do something else. So I have to create a new column by double clicking. Let's call this XC for centered. And I need to create a formula using initial weight. So I'm going to right click and go to formula. And so what I want to do is I want to do initial weight minus the average of initial weight. So I'm going to click on initial weight, minus, then I'm going to go down to the statistical option, and then select column mean. So this is going to take the average of whatever column I put in there. So I'm going to select column mean, and then select initial weight. That's all you have to do. Hit OK. So now these are going to be centered values of my covariate. If I wanted to check to make sure that was true, I can go to Analyze and then Distribution. So I'm just checking what the distribution is of XC, and I'm hoping that the mean is 0 because the sum of it should be 0. And in fact, I see that the mean is basically 0. So this is just looking at the distribution of my covariate after it's been centered. Okay, so now let's say I do an analysis ignoring the covariate. So I'm going to go to Analyze and then Fit Model. I'm going to select N weight and put that as my response. And then Treatment. I'm just going to fit this simple model, ignoring the covariate. So I'm going to select Run. And we see that there's no difference between the treatments, which is surprising given the fact that we saw with that analysis of covariance type plot that there was differences between treatments. So the problem is that our mean squared error is quite high because we had such a wide range of initial weights. So I'm going to keep this up just for us to do a comparison. And then if I go to Analyze and Fit Model again, I could fit the model with the covariate. One faster way that I could actually do this is rather than having to go through it all over again, I could go back to this original analysis I had, click on this red arrow, and go down to Model Dialog. So this is going to pop up the analysis, the fit model window that you had to generate this output. So I can just add things to it. So I want to add actually XC to do a centered analysis. And I want to add the interaction between treatment XC. So I would want to pick treatment and then XC and then select cross. So this is going to be doing an interaction covariate model. Now we didn't really have much evidence that we needed an interaction term from our graph builder, but I'm just trying to show you how you can do it. So I shouldn't expect this to be significant. So let me go down to look at my effect tests. I'm going to ignore my parameter estimates. And so this is fitting a model with an overall slope that's centered and then individual adjustments for each treatment. And so this test down here is testing whether I need these individual slope parameters given that I have this one overall one. And it doesn't look like this is improving any greater of a fit. So it makes sense then that I should probably just go ahead and drop this from my model. But take a note before we do that about what including the analysis of covariate, or what the covariate did. Before we had a mean squared error of 92.6, and by including my covariate, I dropped this down to 3.269, which is quite a dramatic jump, and this is going to help us be able to establish differences between the treatment. And this also says those differences do not depend on what the covariate value is, because they don't interact with the treatment, which is also a very pleasing result. So if I wanted to remove the interaction, I could do that model dialog and delete it, but I could also go up to this plot right here, select the interaction, and then click remove, and it'll refit the model without doing that. So now we have our analysis for the model that seems most appropriate, just an overall covariate and then individual treatment effects. So what this is testing up top here, this treatment, is this is saying, are there differences between my treatment given that I've adjusted for my covariate? We just saw before over here that this is an analysis without adjusting for the covariate. So the covariate adjustment is necessary. So let me do maybe some post-hoc analysis. I'll go down to my effect details, and then what we see here is in the least squared means for treatment is we see the least squared means and then what the original means were. So this is what happens if I were to just take the average of my individual treatments, ignoring the covariate. So we get 45, 38, and 46. So this is what the usual analysis of variance is doing. It's doing an analysis based off of these means. So whenever you see kind of a dramatic difference between the mean and least squared means, that's kind of an indication that there could be potential bias if you didn't include the covariate. When you see a dramatic decrease in mean squared error, that means that you could have a difference in explaining variability. And so if you go down to LS means contrast, you can do all these options and do your comparison of your treatments, but it would always be adjusted for what the covariate value is, doing those adjusted treatment means. So if I do LS means contrast, it's going to look like just before. And the reason why is because we don't have an interaction between the covariate and the treatment, so I don't need to worry about telling JMP what value of a covariate I want to make my comparison at, because we're doing a model where the comparison will be exactly the same, because there's no interaction with the covariate value. If I add the interaction back, I need to go back to the model dialog, and I do treatment by XC, and I fit this model again. That's not going to be the case. Even though it's insignificant, JMP is still saying you're trying to fit this model. So if you want to do a comparison, if I want to do a contrast, that I have to tell it what covariate value I'm looking at. And by default, it's going to put in what the overall average is. So this is centered, so the overall average is 0. So if I wanted to do a comparison at a centered covariate value of, let's say, 3, I would have to type in 3 right there. And if I wanted to compare treatment 1 and treatment 3, I might do something like this, click done. And if I wanted to see what that actual difference is, I click on test details, and this is the estimated difference when the centered covariate is 3. So hopefully that went over the major points of how to do an analysis of covariance in JMP, and I'll be posting a video soon about how you can do this in SAS, and you can see all the extra stuff that you can do.